This is a question from October, November 2022, variant 41. 1A, which carry 2 marks. State the equation for the gravitational force F between 2 point masses M1 and M2 that are separated by distance R, as shown by this diagram. State the meaning of any other symbols you use. We need to know that the gravitational force of attraction between M1 and M2 is directly proportional to the product of the masses and is inversely proportional to the square of their separation. Therefore, the gravitational force of attraction between 2 objects is equal to G M1 times M2 divided by R squared. The only constant which is not mentioned in the question is G. So you must say that G is the gravitational constant. So this is how you get the 2 marks. For B, a satellite is in circular orbit of radius R around a planet of mass M. Show that the period T of the orbit is given by this formula, where K is a constant that depends on the value of M. Explain your reasoning. To answer this question, you need to know that the gravitational force of attraction between the satellite and the planet provides the centripetal force for the satellite to move in the circular orbit around the planet. Number 2, you must know how to equate your gravitational force, which is Gm m over r squared, to either mr omega squared, or you can equate Gm m over r squared equals mv squared over r. They must introduce the expression for T into the expression. So to get the 3 marks for this question, the first mark comes from the gravitational force of attraction provides a centripetal force. This is a K1 mark. Then after that, you either equate Gm m over r squared, which is our gravitational force, equals to centripetal force, and you must use omega equals to 2 pi over t. Or you can use Gm m over r squared equals mv squared over r, where your v is equals to 2 pi r over t. The reason why you do this is to make sure that the final expression contains your t. Then you substitute your omega into either this expression or your v into this expression. You'll get t squared equals to 4 pi squared over gm times r cubed. 4 pi squared over gm is a constant represented by k. Therefore, your t squared equals to k times r cubed. Then in part C, a satellite is in circular orbit around the Earth with a period of 24 hours. So you can see the period is given to you. And then the mass of the Earth is 6.0 times 10 power 24 kg. Big M is also given. Therefore, you substitute into this expression. Your t squared is known, your r cubed can be found if you know your m. So you substitute your t and m into the expression, this expression here, you get r equals to 4.2 times 10 to the power 7 meter. In part 2, you have to state the other 2 conditions that must be met for the orbit to be geostationary. The 2 conditions are these. These are the 2 conditions for 2 marks. The satellite must orbit above the equator. Then number 2, the satellite must move in the same direction as the rotation of the Earth. It means the satellite must move from west to east. And then this is a summary of the facts that you must know to solve this question. Number 1, you must be able to state and give the formula for the gravitational force between 2 massive objects separated by distance r. Number 2, you must be aware that gravitational force between 2 objects provides a centripetal force for a satellite to move in a circular orbit around another planet, a planet. Number 3, know that you can equate your gravitational force equals to mv squared over r, or your gravitational force equals to mr omega squared. And you must use either omega equals to 2 pi over t or v equals to 2 pi over t, so that you can introduce your t into the expression. Number 4, you must be able to state the conditions for satellite to orbit a planet in the geostationary orbit.